going to go ahead and start off by doing some simplification regarding fractions and variables. So there's two ways that this problem can be written. For number one, I can put this whole fraction under the fifth root, in which case you would do the fifth root of the top and also the fifth root of the bottom. Or I could present it in this format where instead of using a fifth root, I take everything that's in here and raise it to the 1/5 power. So regardless of how you choose to think of it, you would either distribute 1/5 to the 10 and the 5, or you just simply divide 10 by 5 and 5 by 5. Either way you look at it, you're going to get m squared over n to the first. When you have a problem like number 2, the first thing you want to do is consolidate. We shouldn't really have all these letters in here. We can consolidate that down to a single letter. So using my exponent rules, I would subtract 18 and 2 and get 16. P to the -1 can be moved up to the top and make p the +1. In that case, p1 and p to the 7th would make p to the 8th. So rather than doing this, now I can look at doing this, the 8th root of these two items here. Conveniently, they're both divisible by 8, so I would get n squared and p to the first for my answers there. The next two problems are a little bit more work involved. The key is picking up on that we're using an addition symbol and a subtraction symbol. So to add and subtract, your roots have to be the exact same, and right now they're different. So there's a couple different ways to handle this. From an exponential standpoint, we're basically taking the stuff that's in here and raising it to the 1/4 power. And for this, we're taking 2w and we're multiplying it by w to the 6/4. So we want to simplify both of these and see if we have any matches. So I'm just going to distribute the 1/4 in to the exponents, and I would get 16 to the 1/4 and w to the 10/4, but we're going to go ahead and make that 5/2. And over here, we want to change 6/4 into 3/2. The 4th root of 16, or 16 to the 1/4, ends up being 2. 5/2 is the same thing as 2 1/2, so we want to change our exponents so that we have proper fractions. And then once we do that, we can go ahead and rewrite the problem as 2w squared, and then this really means just the square root of w. So we simplified the first term in the problem. Now we have to continue simplifying the second term. So 3/2 is not okay. We're going to change it to 1 1/2. If I do 2w times w, I get 2w squared, and I'll change w to the half into root w. And you just want to be very careful when you're adding. We only add the numbers in front. These are both w squared root w terms. So we have two groups of w squared root w plus another two groups of w squared root w. So that makes 4 groups of w squared root w's. So just be very careful when you're adding. Only the number in front changes. The exponents, the radicands, they don't change at all. When we tackle number 4, the first thing I'm going to do is address the parentheses. Instead of writing p twice, we can just write it once and add the exponents. So if we do 1/2 plus 1/4, we'll get 3/4. Because 3/4 is reduced and it's a proper fraction, we can go ahead and change that to the 4th root of p cubed. So now we're going to go ahead and simplify the second term. You can 4th root 16, that would be 2. You can't 4th root p cubed though, so we just leave it alone. So we have to do one group of quartic root p cubed minus 2 groups of quartic root p cubed. Since they are like terms, we can go ahead and do 1 minus 2. We get -1, but your term does not change. And just know that if you were ever looking at an answer key, they usually don't write the 1, they'll just write negative quartic root p cubed.